Hi, you're so cute. Oh my god. Hi.
Here, girl. Here, girl. Here, here. 我喜欢吃冰淇淋。
Balloony, please report down to the principal's office.
Grr.
Electricity.
Balloony!
After Matt Hughes stabs him, Balloony slowly deflates, and we notice, due to the immense size of our brains, that Balloony's radius is decreasing at a rate of exactly 3 over 320 pi centimeters per second. We also know that his initial radius was 20 centimeters, and now we want to find the dV over dt, or the rate at which the volume changes, so then we can also get a very rough estimate of whether Balloony can survive for 40 minutes before the battle heroes can make it. Looking at the problem, we can first gather our variables and state the unknown of what we are looking for. Since Balloony is deflating, we can assume that the rate at which the radius is changing will be negative as well. The radius is also stated to be 20 centimeters and the unknown is dV over dt. Then, based on the question and the picture of Balloony here, we should also be using the formula for the volume of the sphere. And then we would do implicit differentiation of that equation, so the left side would just be the dV over dt, and then the derivative of the radius on the right side would be 3r squared and dr over dt. However, the 3's cancel, which I didn't show here, so we're just left with the 4 pi r squared dr over dt. Now we can simply plug in our givens, which should then look like this. Plugging all of this into the calculator should give us a value of exactly negative 15. The units are in centimeters cubed per second, since this is the rate at which the volume is changing, and this is when the radius is 20 centimeters. Then the question asks us to find the estimated time that it would take for Balloony to deflate. An important note here is that this will be a very rough estimate, since normally the volume of which a balloon changes as it deflates is not constant. However, in the context of this problem, we will disregard that for the time being and treat it as if it was constant in order to give an approximate value for time. To do this, we will go back to the original volume formula, and now we will plug in the 20 centimeters for R to find the very initial volume of Balloony. And then we will go back and divide this by 15, treating it as if the balloon constantly did decrease at a rate of 15 centimeters cubed per second. This number would then be divided again by 60 to get the time in minutes, which was specifically asked for in the question. All of this ends up with a number of around 37.23 minutes, and so Balloony will unfortunately not survive until the battle heroes arrive.